Good morning, friends. Am I audible to all?
Good morning, sir.
Good morning. My screen also visible?
Yes, yes.
Okay. Let's start the today's session. Today we will learn users, groups, and permissions. In last class, we have learned about the monitor resources. How you can monitor CPU information, memory information, CPU and memory utilization, network related information, processes related information, Linux server logs, and how to check the server uptime. These 7 topics we have covered yesterday. So today we will learn about the users, groups, and permission. Users. Every user is assigned a unique user ID, number ID, that is UID. UID 0 identifies root. Let me show you. Users name and UIDs are stored in /etc/password PASSWD, not PASSWRD, PASSWD. This is the configuration file which contains all the password information, user information of the Linux operating system. Users are assigned a home directory and a program that is run when they log in, usually a shell. Users cannot read, write, or execute each other's file without permission. That means the documents or files located in user's home directory not accessible by the other users. So let me show you cat/etc passwd. Cat is the command to list the contents of a file. You can see these are the all users information listed in the /etc/passwd file. So if we talk about the root user, you can see root user is a administrator user in the Linux operating system, so its user ID and group ID is 0. If you talk about the other users group ID will be start from the 1000. That means 1000. It is the Linux operating system mandatory thing. That means all users group information and user ID will be starts with 1000. That means Vishnu is the first user, so having the user ID 1000 and group ID 1000. But in case of root user having the group ID 0 and user ID also 0. And root user's home user is /root, and in case of Vishnu, home directory is /home/Vishnu. Likewise, other users home directory also in located in /home. And any user cannot access the documents in their home directory. User are assigned to groups. Each user is assigned a unique group ID number, that is GID. GID are stored in /etc/group. Each user is given their own private group, can be added to other groups for additional access. That means whenever we will create a user, at that time a single group ID will be assigned to that user having the same name. Let me show you here. This is a user, its user ID is this one and group ID is this one. But if we check the group ID of the Vishnu user, you can see user ID is Vishnu as well as group ID is also Vishnu. That means by default, whenever we will create a group user, its group ID will be assigned with the same name. But in case of any requirement, we can also add the additional groups to a user. So group information stored in the /etc/group. Here you can see Vishnu group information is stored here. Group ID is 1000. User mode -a-g group 1 group 2 username. That means if you want to assign additional groups to a user account, then we have to use the -G option. Using the -G option, we can add additional groups to a user. all users in a group can share files that belong to that group. That means whenever we will add a common group to multiple users, all users can share their documents among them. Create a new user and assign groups in one command. User add -g username Nathan. That means whenever we will create a user, by default it will assign a group ID. In case we want to change the group ID, using the -g option we can change the group. User add -g users capital G will developers Nathan. That means here we are assigning multiple other groups to the Nathan user having the option capital G. Displaying user groups ID username. Whenever you will use the ID command with a username, it will display the user's information including user ID and group ID. User supplementary groups are groups username. That means using the groups command, it will provide the supplementary groups. Likewise, wheel developer, these are the supplementary groups. Create a group. Group add group name. That means using the command group add, we can create a group. Let's check here. We have created a sample group. Then we will add the user. Okay. Delete a group. Group delete group name. If you want to delete a group, we can use the group delete command. Group name sample. Using the group delete, we can delete a group ID. Change a user's primary group, user mode -g, group name, username. That means user mode -g sample, then username is Vishnu. Then ID Vishnu. You can see Vishnu users group ID is changed to sample. Previously it was Vishnu. Likewise, we can also change the group ID of the user. Then removing a user from a group, G password -d username group name. This is the command to remove a user from a group. That means if a user added to multiple groups and we want to remove that user from a group, at that time we can use the G password -d username group. We have created another group sample1. Then we will add this group to Vishnu also using the command usermod usermod -a minus capital G sample1, then Vishnu, Vishnu, and ID Vishnu. You can see Vishnu users group ID added to sample1 and sample1 and sample. Two groups are assigned to Vishnu. If you want to remove one group from the user ID, user G password -D, username is Vishnu, then group name is sample1. Now check. You can see only sample is present. Likewise, we can assign group and also assign the remove the groups from a user ID. So the all users present in that group can access their files between them. Is it clear to all?
Yes, sir.
Linux file security. Every file is owned by UID and GID. I have already told you user ID and group ID assigned to a user, and same also same as like same user ID and a group ID assigned to a file. Every process runs as a UID and one more GIDs, usually determined by who runs the process. Three Three access categories are processes running with same user ID as the file user, processes running with the same GID as the file group, and all other processes as a other. That means let me show you. In case of sample script, this is a script file. This is assigned to root user and also group is root. This is the user and this is the group ID. Permission precedence. If UID matches, user permission apply. Otherwise, if GID matches, group permission apply. If neither matches, other permissions apply. That means here you can see three parameters are here: user, group, and other. That means from first read, write, and execute, this is for user. Then read and execute, this is for group, and read and execute, this is for other. That means whenever this permission matches, whenever a user try to work with a file or a directory, at the time these permissions are matched. If the first permission is matched as with the user, it will work. Else it will check for the group, then it will check for the other permission. Likewise, one by one it match the permission and it will make accessible to the user. Four symbols are used when displaying permissions. R stands for read, W stands for write, and X stands for execute permission. Dash means no permission. Here you can see read, write, and execute. Here you can see only read, no write. That means here a dash is present, and then again execute, then read, dash, execute. That means for user, read, write, execute permission present. For group, only read and execute, and for other, read and execute permission is present. Let me brief you. Read, write, and execute. Read, write, and execute. Read, write, and execute. This is for user, group, other. Here D. D means D means this is the file type or directory. That means it is a directory. then read, write, execute permission for user, then read, write, execute permission for group, then read, write, execution for other. If I talk about this file, if we talk about this file, sample.script, here user is root and group is root. That means here, in case of user, root having full permission, group having full permission, then other. Other means any other user, other users having the full permission. If we talk about this file, here no directory, that means it is a file. Read, write, execute. This is root having full permission, then group also root having read and execute permission, other user having the read and execute permission. That means the root is the owner of this file and having full permission, and root group, that means other users added to the root group having the read and execute, they cannot write any file and make changes to file, and other users also cannot make modify to the file, they can read and execute the files. That means any other can execute this script file, because it's a script file, any other user can execute the file. Okay, let us try this one. Now I am in Vishnu user. Okay, cd/ll, sorry, cd/root. Okay, you can see permission denied. That means Vishnu don't have the permission to navigate to the root user's home directory, because /root is the home directory of a root user. I have already told you, no users having the permission to navigate to the other user's home directory. Likewise, Vishnu user unable to list the contents of the root user. What we can do? We can copy the file, we have copied the script file to the slash, then move to slash and check the permission. Script has the permission, same permission. Now in Vishnu user, cd/, you can see sample present here. Now you can try to execute, because read, write, user group and other user having the execute permission, we can execute this. You can see welcome to Linuxehub. That means it is allowing me to execute the permission, execute the script file, but cannot touch the sample because permission denied, because it might be trying to create touch files or create files to other users directory. So let us try to modify this and add some contents to the script file and check if having the right permission or not, because here it is clearly showing that other users having no right permission, and we will check it. You can see read only. We cannot modify and we cannot add any contents to this file, because no other users having the permission to write this the file. Okay. Likewise, permission of a file or a directory works. Any doubt? Anyone having any doubt? Please ask me.
No, sir.
Okay. Examining permission. File permission may be viewed using ls-l. ls-l/bin/login. It will show the entire permission or entire information about the file. ls-l, you can see using ls-l option command we can check the permission of a file. Then file type and permission represented by 10 character string. I have already told you this is a 10 character string. This is a 10 character string. 1, 2, 3, 4, then 5, 6, 7, 8, 9, 10. This is a 10 character string. Interpreting permissions. Read, write and execute for owner and owner Anderson. Here, sorry, some mistake is there. Here, read, write and execute permission to the root user and read and execute for the group and no permission for the other users. If I talk about this my script files permission, having no permission for the other users and only full permission to the root user. Changing file ownership. Only root can change a file's owner. Only root or the owner can change the file's group. Ownership is changed with chown command. Group ownership is changed with chgrp, and the command will be chgrp minus capital R group name, file or directory. Likewise, owner also change with the command chown minus capital R username, file or directory. Here you can see script file having the permission to the root user and the group root. If I want to change the permission to the Vishnu user, what I will do? chown owner, chown, that means change owner, BISHNU Vishnu, script.sh. Now check, ownership is changed to Vishnu. If I want to change the group also Vishnu, I can do same like CHCRP BISHNU Vishnu script file. You can see user and group both are changed. Using the chown command, you can check the user permission. chgrp, you can change the group permission of a file. Is it clear to all?
Yes, sir.
Yes, sir.
Okay, great. Changing permissions, symboling method. That means here you can see there is symboling method. Read, write, execute, read, write, execute. These are the symbols. So chmod minus capital R mode file. Mode file, where mode is user group and other for user group and others, plus or minus for grant or deny, read, write or execute for read, write and execute. These are the combinations we can using change the permission of a file. So examples are user group other plus R grant read access to all. That means whenever you will use this command ugo plus R, then file name, it will change the read permission. That means it will allow the read permission to the file for user group and others. Then O minus WX deny read and execute for others. That means here only O is other minus read and execute. It will deny the, that means it will modify the permission and it will modify write and execute permission from the other option, other users. Changing permission numeric method, which is very easy and not remember to any command. That means it is very simple to change the permission using the numeric method. Use 3-digit mode number. First digit specify the owner's permission, second digit specify the group permission, third digit presents the other permission. That means here already I have told you user group and other. Then 4 for read, 2 for write, 1 for execute. then chmod 640 my file. This is the numeric method. Previously we have learned how to give the permission in the symbolic method. Now we will try with numeric method. Let me clarify you here. 421, that means 4 means read, then 2 means write, then 1 means execute. Read, write and execute, and if I sum them it will be 7. So if I want to give full permission, that means read, write, execute, you can see here. If I modify this one, dash 421, then again 4 dash 2, sorry 1, sorry 4 dash 1, 4 dash 1. This is the numeric method. 4 to 1 means, if I will convert it to 7, it will be 7. That means 4 to 1 7, and here 4 1 5, 5. Here also it will be 5. Then okay. So here this means 4 to 5 means 4 to 1 means 7. 4 2 plus 6 plus 1 5 7. Here 5, here 5. That means if I want to give the permission this type, I can use the 755. Okay. So what will be command? chmod 755 script.sh. This will be the command 755. If I want to give full permission, can anyone tell me what will be the command? If I will give to full permission, that means read, write, execute, and for user, read, write, execute for others, and read, write, execute for the group also. What will be the command in numeric method? Can anyone please tell me? Anyone please tell me? It will be 777. You can see 7 means read, write and execute. That means 4 2 1 1. Okay, any doubt here? Anyone having doubt?
No, sir. No, sir.
Sir, actually, I have a doubt of.
Please tell me.
Hello.
Yeah, please continue. Tell me.
Sir, 4 minus 1, that will be 3 now. So, it's a fixed command.
4
7
minus
5.
1.
Yeah.
No minus, only addition. 4 2 1 means 4 2 6 plus 1, it will be 7.
Okay.
Okay, that means full permission. Here what happened? Write permission not present, so here it will be 0.
Yeah.
That means read is for 4 and 1 for plus for execute. That means 4 1, it is 5.
Right.
If here I want to give the write permission, then here I will add 2. That means then it will be convert to 7.
7.
Got it? Got it?
Yes. Yeah.
Okay, great. So if I want to give the only full permission to the root user and no permission for the other users, so what I will do? I will give the command chmod 700 script file. This will be my command to only give full permission to the owner and no permission for group, no permission for others. Okay. So we can use any combination. Special permission for directories. Special permission we can give using the sticky bit. Sticky bit files in directories with the sticky bit set can only be removed by the owner and root, regardless of the write permission of the directory. How can we provide the sticky bit permission? chmod plus t directory name. That means using the plus t option, we can add the sticky bit to a directory. Removing sticky bit, use the minus t option. What is the sticky bit? Let me clear you. That means whenever a directory let's create a directory. Let me explain here you. mkdir sample already created. Okay, no problem. Sample directory is already created. Okay, having the roots user permission and group also root, and all root having the full permission, other users having the read write read execute permission, and root group having the read and execute permission. Here what we will do, we will give the permission, full permission, chmod 777 sample. Now you can see I have given full permission to the user group and others. Now what we will do, according to the permission, any one user can create a file and delete a file from that group. It should be. So let's go to the sample directory. Okay. Now I am in sample directory. I will create a file poucs.vishnu.txt. I have created a Vishnu file having user Vishnu. Now I am in, you can see now I am in Duke user. This is the another user, cd sample. Now I am in sample directory. I will create a text file here. Okay. Now you can see one file is created by Vishnu user, another file created is Duke user. So I am in Duke user. As there is full permission to that sample directory, Duke user should delete the file created by the Vishnu. It should be, because I have given the full permission. Let's write rm-rf vishnu.txt. You can see Duke user can delete a file created by the Vishnu user. So likewise, Vishnu user should delete the file of a Duke user. Okay. So what happened? It should not be possible in the real-time environment, because one user's file cannot be deleted by the other user. So how you can restrict it? We can provide the sticky bit. So let's try it. Again, we'll create files. toucs dots Duke.txt having the with the Duke user. Then we will create here another file Vishnu.txt with Vishnu user. Then Vishnu and Duke file created. Now we will provide the sticky bit permission. chmod plus t sample. Now we can see here one T symbol is added. Is it visible to all? T symbol is added here. That means whenever you will check the permission, you can identify using the T symbol. That means sticky bit is added to the sample directory. So now it will restrict one user's file cannot be deleted the another user. Previously it was possible. Now we cannot delete. That means now we are in Duke user. We will try to remove the Vishnu user's file. rm-rf, that means rm with remove forcefully Vishnu file. You can see operation not permitted. That means it is not allowing the Duke user to delete the Vishnu user's document. Even if I have used the option -f, that means forcefully, I am trying to remove the forcefully, still it is not allowing me. So let's try in Duke user as well. Sorry, I have already tried with deep user. Now try with Vishnu user. Array minus array div test. Operation not permitted. So sticky bits usage is like this. If we will provide the sticky bit permission, it will not allow the users, even if they are permitted and even if they have the full permission, they cannot modify and they cannot delete the each user's file by the other user. Is it clear to all?
Yes, sir.
Okay.
Sir, repeat please last statement once.
That means whenever you will apply the sticky bit, at that time, even if having the full permission to a directory, it will not allow one user's file deleted by the other user. It will be restricted.
Mhm. Now clear.
Okay, great. So we have completed today's session. Today we have learned about the /etc password. That means how to create users, group information /etc/group, special permission sticky bit, and all files are owned by one user and one group. The mode of a file and made of three permissions: user, group, and other users. Three permission may be granted or denied, read, write, execute. And we have also covered how to create groups and how to add groups to a file or directory. These all things we have covered today's session. Anyone having any doubt, please ask me. I will try to clear.
Sir, please add previous 3 classes lectures video.
You are not audible clearly. Tell me again.
Sir, previous 3 classes lectures video I want in a group.
Okay, okay. I will upload today itself.